for our first part of this lesson 4-1, I'm just going to go through some of the terminology to start. So let's get started on that. If you look at the packet, we just need to first start by clarifying the difference between a scalar and a vector. So, and we've talked about it in class, but a vector is two parts. It's got magnitude, which is the number itself, how long is my arrow, but the other component is it has to have a direction for that magnitude. So the difference between a scalar and a vector, as I've already noted here, is that a scalar is just the number only, magnitude only, there's no direction. And a vector then takes the magnitude, if you give it a direction, a certain number of degrees from the x-axis, things like that. That gives you a vector. And then we moved on and we defined what the parts of a vector are. So you have an initial point, you have terminal point, in this case we call them PQ, and then you can label a vector as such, PQ with the half arrow above it. More common, or I guess just as common, would be taking the vector R. So we labeled the endpoints P and Q, but the label of the vector itself, we call it R. And I'll use that quite often actually. It's R stands for resultant. So if we have two different vectors we add together, I'll call the resulting vector R. In this case, we're just calling it R. Anyways, you can say PQ with an arrow, half arrow, you can call it R with a little half arrow above it. Or in this day and age with technology and keyboards, it's really hard to get that symbol into a computer sometimes. So somewhere down the line, they decided that if you just take the letter of the vector and make it a bold font, that also works. The only other terminology we've needed to, or have discussed in class at least, is standard position. And the idea behind a vector in standard position is that all you get is the coordinate, xy coordinate of the endpoint where the arrow is. So standard position starts at 0, 0. And we will also note that component form here just shortly. We'll talk about what that looks like. Direction. The symbol I put over here, theta. Direction for our case, our purpose, is the angle at which you've gone around the origin, starting at the positive x-axis. So this is kind of like the unit circle. Okay, so 0 is the positive x-axis, and then you go around the circle 0 to 360 from there in a counterclockwise direction. Later on, so, and this should say section 4.2, let me change that right now. Section 4.2, our next section, we'll actually start doing applications, sort of. So airplanes, boats, those kinds of problems we've been working on, they actually use a different method of giving the direction of the vector. And what they call that is a heading or a bearing. And we'll get into it more, but basically a heading or bearing uses true north, so the positive y-axis, as 0, and then you end up going clockwise around the circle. The other terminology here is magnitude, and if we wanted to find just a magnitude of a vector, in that case, what we find is it's noted as the magnitude, or sorry, the absolute value of whatever vector. In this case, we chose v. But basically, it's that straight line distance between the initial terminal points. So kind of using that distance formula. Okay. So as long as you add any two vectors, they are using the same units. You can't use one vector that, we'll get into units a little bit later, but if you use one unit of vectors in inches and the other one in feet, that doesn't correlate. But that's for later. Real quick, too, before I may just end this video with the terminology here, but component form. So the other term we use, the last thing we talked about in class already, is the component form. And here we use the endpoints A and B with a line like a half arrow over it. But what we wanted to do, what I wanted to note here is if we wanted to write the component form of vector AB, we know that point A, excuse me, we know that point A is at some coordinate x1, y1, and B, the end point, the terminal point, is at x2, y2. If we want to get that so that it is what we call in component form, all you have to do is take the, well, first of all, our notation, which we've talked about in class, is the triangle brackets. But anyways, all you have to do to get it into component form so that the start initial point goes to 0, 0, is you just take the x values, so x2 minus x1. So you subtract the x values, terminal point minus initial point, and then the same thing, y2 minus y1. And once you do that, whatever your numbers end up being, what you find is that coordinate, that new coordinate x, y, is the terminal point, and the component form then allows so that the starting point of that vector, whatever those numbers are, ends up being a component form vector. So if we want to maybe see an example here, I'll use black ink, and I don't know, let's just draw out the quadrant 1. And let's say point A up here, let's call it 1, 2 is where it starts, and it ends at 3, 4. So if we look at this, point 1, point A, our initial point, 1 up 2, okay? And point B, our terminal point, 3, 4, 1, 2, 3, 4. So here is, A, B, there we go. And what we're saying is, if we run the numbers, we would say x2 minus x1. Well, x2 is 3 minus 1, so we would have 3 minus 1, so 2, comma, y2, 4 minus y1, so 2, 2. So let's check. And I think that's 2 1/4. We start at 0, 0, and we go to over 2, up 2. So this slope, the rise over run from A to B, is we go up 2 and over 2. And if you check the component form in standard position, the 2, 2 says we start at the origin, we go over 2 and up 2. So that's just one quick example on how to do that. And then next we'll look at finding the component form of AB. So again, all these are is just, we're going to write out the triangle and we say x2 minus x1, so 3 minus -4 is our x, and -5 minus 2 is our y, which reduces to 7, comma, well, let's see, -5 minus 2 is -7. And so we can do this one too. -9 minus 0 and -3 minus 8, which reduces to -9, comma, -11. So again, just getting a random, like point A to point B to be a standard position starting at 0, 0 is just that simple. It's just x2, x1, and y2 minus y1. And let's end the video there.